All right, so after the simple algorithm, we talked about the greedy algorithm, where we always load the heaviest remaining item that'll still fit on the truck. And that, on average, will tend to give us a better solution than the simple algorithm. And the simple way of doing that, you just sort the items in descending order first using the built-in sort function in MATLAB, and then do exactly the simple algorithm again, and you will be doing the greedy algorithm. But what if you can't sort it? What if there's some practical reason that you don't want to sort them first? Let's think about how you can do the greedy algorithm without sorting. All right, so now here's our list of weights, not sorted. What this means is now we're going to have to look through the whole list each time and pick out the heaviest remaining one that fits on the truck. All right, so we look at this list. We ask, what's the heaviest one that's less than our remaining capacity of 1,000 pounds? And that's the 825. So we load that. Now we've got a remaining capacity of 175. And we look through the whole list and ask, which of these is the highest one that's less than 175? And it's 120. So we load that. Look at the remaining ones. What's the heaviest remaining one that's less than or equal to 55? It'll be the 10. And now there are no remaining weights that are less than or equal to our remaining capacity of 45, so we stop. All right, so the question is, how do we then look at the whole list each time, or the whole list of remaining weights each time, and decide which one is the heaviest that'll fit on the truck? That's the tricky part of this whole algorithm. And it's easier in MATLAB than it would be in other languages. In other languages, you would probably just have to use nested loops and loop through each time. But in MATLAB, what we can use is the max function in conjunction with logical indexing. Okay. So if you look at that, that says, give me the heaviest weight that's less than or equal to the remaining capacity. Right? So the logical indexing only picks out the ones that are less than or equal to the remaining capacity. And then we take the max of those. And that's the next weight that we load. Now, the condition for stopping is a little different. In this case, it's not just a single pass through. We have to keep going until one of two things happens. Either there are no weights left, right? So we've gone through the whole list, loaded everything, or the remaining capacity is no longer greater than any of the remaining weights. Okay, so if we, in other words, we keep going as long as the remaining capacity is greater than or equal to the smallest remaining weight. That means at least one of the weights will still fit on the truck. If this is false, all of the remaining weights are too heavy to fit on the truck, so we stop. Now, it's shown as two different decisions here, but really, we can do that with a single while loop like this. Okay, so while, now I'm going to show you in a second, another thing we're going to do differently in this case is, once we load a weight, we're actually going to remove it from the list to make sure we don't load it again. We didn't have to do that last time because we were just making a single pass. But here we're looking at the whole list each time. So once we load a weight, we need to get it out of that list so we don't load it again. All right, so that means if we run out of weights, if we've loaded everything, the length of weights will be 0. All right, so as long as the length of weights is greater than 0, that means there's at least one weight that we haven't loaded yet. And if the remaining capacity is greater than or equal to the lightest remaining weight, that means there's something we can still load. Right? So as long as both of those things are true, we keep going. Now here's the trickiest part. So again, here's how you remove an item from a list, from an array. You set it equal to empty brackets, and that removes it from the array. But which one do we remove? How do you figure that out? Because this line only gave you the value of the weight. Okay. So this, let's say this is 250. Okay, just suppose in a particular case it's 250. Well, we know we loaded a 250-pound weight. Now we have to go find where was that 250-pound weight in the list so we can remove it. And you can do that with the find function. And just think about what goes in here. It's not that complicated. Just look for a weight that has this value. And that's pretty much it. Right? So while loop, decide what the next weight you're going to load is from this. Of course, subtract that from the remaining capacity. But then the key here, actually remove that weight from the list and use the find function to decide which one to remove.